talk about how space really affects individuals, communities, and society at large. You know, a lot has been stated in this conference about linear change moving to exponential change. I think space has been in a geometric change lately. If you think about commercial space, and you go back 15 years, we talked about the big four. There were like 4 big companies. There were maybe 10 companies in the world who could build sophisticated satellites. Communication was done from geosynchronous orbit, by satellites the size of airport shuttles. And remote sensing was done behind locked doors in government buildings. And that was space and how it served us. And what's really interesting, I find, is how it has now, space capabilities have snuck into our daily lives. And to a large part of the community does not realize that what they're feeling or the changes they that are taking place in how they communicate and the capabilities at their fingertips come from space. I think a lot of I heard a neighbor's child recently talk about GPS being in their phone, and what do you mean satellites? You know, they didn't realize their app was talking to 3 or 4 satellites at any moment. But we're in an enormous change where satellite technology is now all over the world. Satellites have always been global in that they've gone around the planet, but now they're global in that they are being built around the planet. And as noted earlier, more and more participation in the UAE and many other countries. So we're at a very interesting, very dynamic time where there's incredible opportunities, also some risks, and we'll get into that. So let's dive right into some of the big questions about commercial space and how it's affecting us. The first one is, what are the most transformative commercial space applications today? And which emerging technologies have the greatest potential to change life on Earth? And Candace, in Seraphim, you touch many, many technologies. Could you start us in that conversation?
Yes, I can. And also, you know, when I was 5, I received a toy Sputnik to put on the Christmas tree in 1957 when the first Sputnik came. And, you know, my dad did the first satellites for the United States government, and then he did the first private satellites for the world. And so, you know, I have a little bit different perspective on space than most people because I've always lived in space and lived with space. And so I looked back when I got your question, you know, I looked back and I said, okay, what was it like, you know, when we were first launching the first satellites and going, you know, into space and everything, and, you know, going to the moon? And of course, at that time, you know, there was Velcro, there was semiconductor, there were mobile communications. All of that came with our going to the moon. And so today, I also thought, all right, what is the most transformative technologies? And I think it is the new materials. So, you know, such as the carbon fiber composites, graphene, materials with super thermal capabilities. All of that combined with robotics, AI, 3D printing, that all together are going to provide new platforms for new space exploration. So that's what I think.
Awesome. Dan, what would you add?
So I would say for me, it's communications, right? When I started with OneWeb, right, we had this idea. We had this idea that we needed to help bridge the digital divide, right? There were 3 billion people in the world that didn't have access to broadband services, people that lived in remote places in Africa, in the far north, in Asia, right? And they didn't have access to the internet like the rest of us do in the developed world. And you know, for us, the idea that we could transform their lives, we could provide them a service with broadband internet was what inspired me to join this mission 10 years ago to go off and build this system. And it's been quite a journey, right? Because we didn't have just the space segment that we had to build and populate. We had to build ground network all across the world in order to enable this technology. And I think that's something that's, when you look at a LEO communication system, that's a little bit hard to grasp. You're not building something that's just for a country or an entity. You have to build something that spans the globe to bring that. And so it's not just one place or one location that benefits from the technology. It's everywhere. And for me, that transformative development is really cool. And I remember when we went live in the far north, there was a little bit of a special on PBS in Alaska. And they were showing someone in a village, they'd never had broadband service before, and they're able to bring up a YouTube video and learn how to fix their washing machine, right? What's more transformative than being able to fix a piece of technology in your home for the first time?
I know that feeling. Yeah, no, thank you. And we'll talk more about communications and what's changing there. Jeff?
Yeah, I'm going to take a different perspective on it, and rather than focus on one technology or one product, and I'll mention a couple. But for me, the biggest change in the space age is today we have capability and opportunity. And what I mean by that is, you mentioned going to the moon. Well, you did research there for 4 days, 7 days. Then we spent billions of dollars, and we got the U.S. space shuttle, and you had opportunities to do research for 2 weeks occasionally. And now, then we got the International Space Station, and you could do research around the clock for years, and then you began to see semiconductor, biopharma. You still had some problems because it's government regulation, and it's been holding us back. And now we're entering the era of private space stations. At Voyager Technologies, we're doing Starlab, permanent station, and our partners, Mitsubishi, Palantir, MDA, Airbus. The excitement is we're on the verge of having the ability to do cutting-edge research with cutting-edge hardware, and from there will come the answer to your question. But what you get now is that opportunity to have the breakthroughs, to have the technology, the products that will change our lives here on Earth. So rather than just cite, this from the International Space Station or this, it's now that we're permanently in space with humans and researchers.
All right, well, I will pin you down on that, but that's a good start.
Okay.
Ben?
Yeah, thanks, Dan, for setting this one up. It's an incredible question, and I think it's the question that everybody has about the space industry. Like, what is going to be the new thing in space? Like, what is the future of space travel? It's been, telecommunications, Earth observation, defense applications for so long. Like, what is going to be the next game changer? And I think it's going to come from an application on Earth. It's going to be a problem that's like, this is a problem we have on Earth. We got to figure out a way to do it better. And it just turns out that the best way to do that is in space. I feel like a lot of people are trying to almost start with space and move backwards, and you really want to start from the problem on Earth and move up from there. And I kind of stumbled into this, right? Like, I worked at SpaceX as an intern in 2016, 2017, and I realized, like, going to Mars is this huge, cool, big idea, and we have the rockets ready, but it's not solving a problem here on Earth, and that always kind of bothered me. And it's everything too. It's like we have problems on Earth, and space can't address them correctly, right? And you can't start with it in that way. So with my company, what we're doing is we're solving the energy crisis on Earth. So we're burning so many fossil fuels, and we don't have a great way to replace them. And it turns out the best way may be in space. You may be getting sunlight from space, which is an infinite resource up there. You just capture some sunlight and then send it down to something on the Earth, and you can solve the energy crisis and potentially replace fossil fuels. And maybe the best way to solve the energy crisis is from space. And I think that's like something that nobody was really thinking about. Even I wasn't thinking about it. I was completely surprised when I came up with the idea. I was actually trying to solve the problem on Earth first, and it turned out space was the best way to do it. I think that's where we're going to see the most innovation, is starting with a hard problem and then like innovating and realizing that space is the answer.
Yeah, well, as I think Kevin's panel said, it starts with the customer. So
Yeah.
there you go, for all of these technologies. Well, let's move a little further into communications. Dan, Eutelsat has been around and has been one of the big four in the earlier era of where GEO dominated. But now we have a situation where there are huge constellations, and of course you're in the middle of one of those. But I mean, yours is even dwarfed by some of the other ones, right? I mean, there are people putting up or planning to put up tens of thousands of satellites and a number of constellations. But there's a whole discussion about what's the role of LEO satellites and constellations, and are the large geosynchronous satellites that have always been right there for us in one place, are they going away, or how do they work together? What's the future look like?
Yeah, so when Eutelsat and OneWeb came together to form Eutelsat Group, I think it was based on the idea that there is something there, right? You have a low Earth system that has some amazing characteristics to it, right? It's got great responsiveness, low latency, but there's a bandwidth limitation, or there's somewhat of a bandwidth limitation, particularly with how many satellites you need in order to meet the mission need. And you have a geo solution, which is there. It has enormous capability, but there's latency. And so by bringing the two together, you're able to provide a hybrid solution that can play off both. And it really depends. It goes back to what the customer needs, right? If the customer is sitting there, they need to do not a YouTube call, they need to do a Teams call, right? They're trying to do a teleconference, they're trying to work something out. You need a LEO system for that. You need something with low latency where you can communicate quickly and get the response back so that the person doesn't notice. I think the lag time for a human is something around quarter of a second or something like that. You need to be able to get that kind of human touch feel through the system. Same with even browsing the internet, right? You click the button, you want that page to load right away. But you don't necessarily need all of the content instantaneously. Right, you have a lot of the content. If you're starting that YouTube video, sure, you want the first little bit to show up right away, but you can buffer off the geo satellite. Streaming something for Netflix or for some other high bandwidth application, there's a lot of potential to bring those two together, build them into the same station, apply quality of service rules, and then you get the data that you want with the time that you want. And we're using those resources as best we can. We're not congesting the LEO network with, the high bandwidth services that can have a little bit of time lag.
And if I may, Dan, it's just so refreshing to hear you, because I was on the original team of Iridium, and so indeed, with the bandwidth restrictions, and then I'm one of the founders of SES and chief architect of SES Global, and so very much a geo person, and I always say different strokes for different folks, and I have been concerned about the focus by a lot of people on just the LEO constellations, because having done Iridium and knowing that the DNA of LEO is narrowband. And you can send up as many satellites as you want, but it is still DNA, it still is narrowband. And so to try and paint a donkey like a horse just doesn't work. So I think that I am such a fan of different strokes for different folks, using GEO for broadband applications, using LEO for narrowband applications, and MEO for other things, and having this really multi-orbit strategy now that is coming into place, and being able to play off each other orbit. I think this is so important.
Well, let me jump on to add on to the comms part of the discussion. Laser communications is now, very much proven in production. Isn't completely fielded yet, but I mean, we're in the early laser communication age, if you will. What will that do? What will be the effect on the architecture, and what will it mean to the person on the ground?
Yeah. So I think that there's a lot of potential there, right? And mainly, I think what it does, particularly if you have a LEO space layer involved, is it gives you a lot of resiliency. You don't have to rely on your ground station links that are connected with cables. Like if you look at what's happened in the Baltic Sea lately, there's been a lot of cables that get sliced. I think that's happened in the Gulf here as well, where by accident or on purpose, links are being broken. And when that happens, even with a LEO system, if you're relying on those networks, those those ground networks, once the data gets to the ground to reach other places, those lines break. You have a big problem. You can't connect to the internet. And laser crosslinks help solve that problem, right? They provide a bridge, and with a dynamic routing system, you can branch on the system. Now, the challenge is that's a lot more capital intensive, right? You got to launch a much more expensive, much heavier, much more power intensive solution in order to do that. So you got to find money.
Jeff, you had a comment?
Yeah, so, Candace said that she's a geo, I think you said guy, but I'll say geo gal. And I'm a space station guy, so I look at everything from the perspective of space stations. And the big advantage for laser communications is the ability for the researchers, for the data to come down. People don't realize how antiquated the International Space Station is. A lot of the research we're doing up there with Voyager, the research packets come down manually when the crew returns. I mean, that's kind of silly, okay? And so with laser communications, we're building into Starlab, the amount of data flow coming down is getting the researchers really excited. So from our perspective, this is a real breakthrough.
And if I may, I mean, I am a geo gal because I'm always kind of fighting for the underdog, and at the moment, geo is it.
Yeah,
when I was with Iridium, let me tell you, I was fighting for Leo. But we were the first. Iridium was the first to use the ISLs, the intersatellite links, with the lasers.
Yeah.
And indeed, when you looked at things like the tsunami, if you looked at Katarina, and the fact that we could have one uplink station, one ground station for the entire constellation of 77 satellites. And today also, with the research that you're talking about, people forget all of this Earth observation data, all of the space situational data, all of this, you have to bring it down.
Sure.
And so indeed, this is a huge problem. Yeah. And the laser ground space links can really, really help as well. So,
yeah, it'll be interesting, and right from a regulatory point of view, it will also be interesting. Well, let's. I want to get Ben into the discussion and talk a little bit more about energy from space. So, can you talk a little bit about how does this work? What do you mean, and and what could it mean to people living on this planet? How would they use it?
Yeah, so it's actually fairly simple, right? You have the Earth, and one half of it is lit up from the sun, and the other half is in shadow because the sunlight hits the first half, and it doesn't make it to the back half. And we put just a mirror in orbit, kind of above the Earth, and we can reflect sunlight down onto that dark side. So it's the fundamental principle is very simple. It's just a flat satellite reflecting some sunlight. But what you end up with is, the mirrors are extremely efficient. They're like 90% efficient. So the reflection is quite good. And then you're traveling through a vacuum after that. You go one pass through the atmosphere like you would traditionally. And then you can use that for any application on the ground. And obviously the kind of end state for this, and the easiest one that everybody's familiar with, is for solar farms, right? We already have these receiver stations that are great at converting solar energy into electricity. And they'll do that with our sunlight just like they do with normal sunlight, just during those nighttime hours when the infrastructure is more critical. And I think for space folks, an easy parallel is telecommunications and replacing copper cables on the ground or fiber optic cables with a satellite mesh network. That's doing all of the moving data around. And with us, instead of moving electrons around in cables, we are moving photons around and then converting them to electrons at the final site. So it's similar in a way, but it's a completely new application in a completely different market. And I think zooming out a little bit, so that's like kind of the nitty-gritty details of how we actually do this. What does it mean for the world? Well, it means we don't have to find energy on the Earth anymore, right? Like, people like to talk about Kardashev 1, 2, and 3. Kardashev 1 is when you're using all the energy on your host planet, right? Like, you're going out, you're burning trees, and then you kind of get better. You start burning coal, you get a little bit better. You start burning fossil fuels, natural gas, right? Maybe uranium, you start making nuclear power plants, but you're really finding things on the planet. Right? And then you have the sun out there. The sun is much bigger than the Earth. It makes more power at 5,000 times a second than we've ever consumed as a species. So like all the oil we've burned, everything, the sun makes that 5,000 times a second. It's completely insane how much power the sun has. And all that energy is sitting out there in space, streaming out into the solar system every single second. And it's a resource. You can harvest it like anything else, and it's easy to harvest with a mirror. You just put a mirror right there and send the sunlight through a vacuum, and it's honestly it's quite simple in a way, but it's harvesting the one of the primary resources in the solar system and bringing it to Earth.
Yeah, that sounds like a game changer.
Yeah.
Jeff, let's move over to manufacturing in space for a minute. 100 years ago, I was on a program called Space Lab, and that was a precursor to the space station. Yeah. And Charlie Walker was an astronaut who was working and developing electrophoresis experiments on space, and we were at the cusp of space manufacturing. And it's felt like nuclear fusion ever since then, that we've always been on the cusp of being able to do amazing manufacturing in space. So can you talk a little bit about, so that's just my, I'm impatient. Can you talk a little bit about, what are the developments that are happening? We heard a little bit on a previous panel about some pharmaceuticals, but what is happening that will enable real manufacturing in space, and how will it be done, and and what will be the effect?
Right. So there were 3 problems with the space shuttle era. We all remember the space shuttle. The first is that the duration time was short. It was just 2 weeks. That's why I'm not a big fan of my friends at VAST when they're talking about the interim platform. It's also 2 weeks, and you really can't do serious research. The second problem was policy. Both in the shuttle era and the International Space Station, we've solved the duration. It's now permanent. But there's a lot of negative policy. And I always say, what's worse, no offense to anybody, but what's worse than one government regulator? Well, 5 governments. And you have 5 governments on the ISS, the International Space Station. The IP is not well protected. There is a lot of money and research that's pent up. They want to try it. But if you can't guarantee that you're going to have your IP, you're not going to invest. Okay? And the third was sophistication of miniaturization. And so we're now coming into this new era where on the International Space Station, we've seen space manufacturing, as they said, of organs, of parts of the eye. You're seeing very interesting tissue manufacturing. You're seeing thin film wafers. You're seeing fiber optics. You're seeing semiconductors go way beyond Moore's Law. It's very, very interesting, but it's limited. It has been limited principally by, in this case, the regulatory environment. So I believe that when we get into private space stations that have a commercial attitude, you've removed the regulatory, you have highly sophisticated equipment. Palantir, as I said, is an investor in Starlab, our space station. What they are doing to ensure that the manufacturing is optimal, the throughput, we can do a lot without humans. So we're really entering, we think we're entering this era, this long-sought era from decades ago, where we're going to get results on manufacturing in the unique environment of space.
All right. Well, it'll be fascinating.
Yes, it will be fascinating.
And it could be very transformative if we can really create new materials.
Yes. And if I could add one thing, what's also exciting, I mean, this panel is how is it going to change our way of life and our well-being? And it's interesting because up to now it's been what we call onesies and twosies. It's been very limited that comes down. But if we can really start to do manufacturing and really bring quantity down in some way of organs and other very sophisticated components, that will be a game changer. So.
Yeah, agree. Let's see. Now, we just had a panel on remote sensing. And it's been interesting to watch the development of commercial remote sensing. Governments have been involved in remote sensing since the beginning of time. What do you think are the technologies that will really unleash remote sensing for industry, for commercialization? Candace, you must touch that world.
I do. But I address it from a different point of view. And that is that actually the remote sensing has so many possibilities. I mean, you know, the IoT, everything it is omnipresent. So my feeling is that the space community has to get out of its comfort zone, and that they have to think of solutions that will be applied to industries and sectors that are non-space. Let me just give you an example, and please, you know, remember I'm a venture capitalist and an entrepreneur, and you know, Jeff, I'm not 100%. I don't know if we'll be able to do scalable manufacturing, because we have looked at that. You know, we've looked at space pharma, etc. But so I'm also on the board of a company that is doing electronic shelf labeling. And it's the largest one in the world. We have Walmart. They have $3 billion contract with them. I have suggested to Walmart and to the World Food Program that space can solve the farm-to-fork solution. And we can. Because we can, there's one of the companies that we've invested in, it's doing Bluetooth from space. So, you know, we can now say, okay, we can track this plant all the way to the fork. And, you know, this is exciting. So, you know, when my dad, when he first went to American Satellite, he founded American Satellite, what did he do? I always talk about pioneering clients and transformational deals. He told Mr. Gannett was a terrible, last media company. He said to him, you know, if you used our satellite to publish USA Today simultaneously across the United States, you would be a winner. Mr. Gannett said, okay, we'll try it. And literally, from one day to the next, USA Today was being published around the United States simultaneously in every single city. You know, so that it's those types of solutions that you have to think of.
Absolutely.
Yeah, and I think it really goes back to what Ben was commenting earlier, right? There's problems, right? There's problems, and sometimes there's a space answer. And you have to look at what space is good for. Space is great for providing us the ability to just get things anywhere very quickly, right?
Instant
point to
infrastructure.
multipoint, right? Instant infrastructure. It solves an infrastructure problem, right? When you look at what happened in the U.S. in North Carolina and California with the recent disasters, you know, communications companies were able to come in with with terminals and provide cell service where the existing infrastructure had been wiped out, right? It's an infrastructure enabler. And a communications enabler, and it provides, you know, for the Gannett solution as well, right? It's a multi-point broadcast system that was relatively easy to field at low cost because it was well suited for that purpose.
It seems like the issue is, though, making that connection. So the anecdote you just told is a perfect example of that. And, you know, and back to the previous panel, AI may be one of the tools that allows non-space literate people to, you know, communicate their problem and have space capability actually solve them. But, you know, whenever you go now, I mean, a couple of times I've gone to local governments and with space solutions, and just the idea of using satellites, it's changing. But the idea of using space is, you know, out of this world. It's scary to a lot of folks.
And many times, you know, I founded Teleport Europe, which got bought by L'Oreal, you know, my first client was Renault in Europe when the wall fell down, and they needed to have sell cars in Eastern Europe. So I went to them and I said, look, you know, we'll just set up stations in the parking lots in Czech Republic, Hungary, Romania, etc., and you can just, you know, set up a little sales place and sell the cars. I never once said the word satellite, but of course that's what it was, you know. So
You got to make that connection.
Yeah.
Yeah, it's infrastructure light. I think that's what a lot of people miss.
Yeah.
It's the infrastructure in space is you have to set it up there,
Yeah.
but then once it's there on the ground,
Yeah.
like maybe you just have to call it in, or it's a small little Starlink terminal. Or with our service, you don't need anything other than a phone, and just tell us your latitude and longitude, and we'll send you some sunlight. You don't need anything on the ground at all. It's all in space, and the flexibility that that opens up is really incredible. You don't need to plan on things happening to have that resource there. Like if you're comparing us lighting up a large area to having a drone ready to go and like a team there that operates the drone and they're ready to go out and they got to drive in a van for 6 hours to get to a location versus our satellite just rotating and sending some sunlight down, it's just a whole different regime.
And I think that's something that gets missed a lot in the conversation is people get very excited about space because space is super cool. Everybody loves space. But the end user, the end customer, they don't really care, right?
Yeah.
They don't
Yeah,
care
yeah.
that the phone knows where it is because there's a satellite telling it. They don't care that they just don't.
They
just
just
don't.
they just want
They just
their
don't. They just
needs
want it to
solved.
work, right? They need it to work and they don't care.
All right, we're going to change to the other side, which is maybe a little bit of the issues. We've kind of been talking about opportunities, and we're running low on time. But the U.S. certainly has a very, very vigorous space program. China is doing quite a bit. Europe is doing a lot, and there are a lot of other countries that have an oar in the water. But is there a space divide that is in place? And space, maybe there always has been, but space was not part of our daily lives, 30 years ago. Now it is. What should be done to link capabilities and abilities and in communities, regions, and work that?
Yeah. So if I may, 4 years ago, I started my campaign against the colonization of space at the B-20 in Indonesia. And I did mention that I'm kind of always fighting for the underdog. And so I'm very, very worried that with these billions, with the frequency, we call it, sometimes you would call it a land grab, but here you're calling it a frequency grab, that there will not be enough space and place in space for what I call emerging spacefaring nations. And so I'm holding a workshop at the IAAF, the International Astronautical Congress in Sydney, for spacefaring nations, emerging spacefaring nations, and entrepreneurs to combat the colonization of space with innovative solutions. When we first started SES in 1983, we had no money, no satellites, no anything. But that's why I like new materials. We recognized that gallium arsenide LNBs, reception equipment, could do with a reception equipment could do what with a satellite that was 10 times less powerful than the 10 times more powerful satellites that were being built in Europe at the time. So, if you have an innovative idea, and that's why I want to tell these emerging spacefaring nations, you need to have precision agriculture. You need to take care of your oceans. You need to do your fishing. You need to do farm to fork. Make certain that you make your place in space. And so that's my campaign.
Oh, go ahead.
Jeff?
Oh, okay. So very quickly, we're at the end. That's all very true, but the United States is stopping many of these efforts. And so let me say that we have a civil space, we have commercial space, and we have strategic space, and it's time we recognize those are separate. And so I welcome us working, for example, as an American with China on civil and perhaps on commercial, but not, of course, on strategic. And yet the view of the United States is if it's space, we'll stop we'll stop everything. So I see, yeah.
And so we have, so Jeff, we need to work together.
Yeah.
Because we can't let this happen.
Right, I agree.
Yeah.
Just a comment to close that part of the discussion. There are different relationships. If you think about airplanes, I mean, there have been a duopoly for a long time, but there are airlines
Right.
in in countries. And so, you know, people can have a piece of the action in their country
Right.
without necessarily having
Right.
the big factory for this or that, and I think there's choices to be made.
Yeah.
We are officially out of time. I just want to thank this wonderful panel for a discussion we could probably have a couple more hours of, so thanks, guys.
Yeah.
Thank you.